Hi everyone, my name is Yanying Wang and I'm a PhD candidate at the university. And currently I'm also a visiting scholar at University of Cambridge. And today I'm very happy to be here to present this work. And this work explores the relationship between robots and pollution. And using spatial econometrics model, we found an unintended spatial spillover effect of industrial robots on air pollution. So we think it's a finding that have somewhat been overlooked by the traditional economics. So first, a quick look at the global trends of robots. As you can see, the industrial robots has grown very quickly and it has played a very important role in economic development. So it can improve the productivity through automation. And since 1990s, it has significant advancements. And during this process, we can say that China is a country that you cannot neglect. So here, this red part is China. We can see that since 2013, China became the leading purchaser of industrial robots around the world. And for the economic benefit, we can say it is very obvious that the industrial robots can alter the economic structure and it can enhance productivity through automation. But for the environmental impact, we think it is not that clear. And there are some literature that are focused on the environmental impact of emerging technologies, and they have some mixed findings. Some find that it will make the environment cleaner, and some find it will pollute the environment. And for the robots specifically, the research is limited, and few of them just focus on the average effects. But we think that there might be ripple effect of industrial robots, which means they will have some cross-border interactions. So there will be some externality outside the local area. So we think environmental spatial spillover effects would be very important. And in this context, it is very important to understand whether the environmental externality of industrial robots exists, and if so, what is the micro mechanism behind?
I just clarify on my question there. So you showed the very interesting shift in share. What do those look like in absolute level?
They are relative levels. So like the percent?
Yes. No. I'm interested in what's the scale of the externality.
Oh.
I understand that this is the share across countries, which is a very interesting breakdown of it. But I know nothing about robots. I should preface this with how far this is growing, or is this leveling off in the countries where the share is declining. But that's giving me the relative levels. I'm interested in the absolute.
Oh, at the absolute level picture, but I think it will be a very steep slope, right? So after like 1990s, there is a very big, rapid development of industrial robots, and especially in China, after 2006. So there is a very obvious increase. And now we will see why it is important to look at the relationship in China. So first, the air pollution in China. You probably know that the air pollution used to be very bad in China. So like around 10 years ago, you will see skies like this. So that left-hand side. And it will have huge health loss, millions of premature deaths every year. And the good thing is the air quality has improved a lot since 2012 because the government has put large effort into pushing forward green transition. And as you can see in this picture, this dashed line is the China's PM 2.5 level. So after 2013, it reduced dramatically. But as you can see, there is still a gap between China's PM 2.5, which is a main pollutant, and the world average. And on top of that, there is still a large heterogeneity in air quality from the spatial level, and as well as the industrial robots. They are unevenly distributed in different areas in China. So they are concentrated in the economically developed coastal areas in China. So in this context, I think it's very interesting to see what is the role of robots in the stage of air pollution control in China. And here is a preview of what we have done. So in this paper, we use the spatial Durbin model to test the spillover effects of robots on air pollution. And we find that when the robots are introduced in the local area will get cleaner and its neighborhoods will become dirtier. And we had a hypothesis. So the potential mechanism could be the firm relocation. And so in our paper, there is a whole section talking about the theoretical model, but here I would like to illustrate it very quickly. So here we could assume that industrial robots are introduced in the local area, and it will obviously change the industrial layouts and the factors endowments, and it will then change the competitiveness of different enterprises. So for the companies with industrial robots and the companies that don't have, they will have different change of competitiveness. And for those that are less competitive, they have two options. The first is to relocate to other places. And the second is to innovate and stay in the same place just to innovate to be competitive. Of course, there is a third option, which is to do nothing, but it will have no influence on our results. So I will just I won't talk about it. So just look at the first option, which is to relocate. And in our theoretical analysis, we found that pollution-intensive companies would tend to relocate to other places, which means they are more likely to move to other places and pollute their neighbors. So this is a hypothesis in this paper, and we would try to prove it in the following sections. So this is the data I use. The main variables are the city level exposure to robots, and we use the industrial level data from the International Federation of Robotics. They offer the number of robots by industry, country, and year based on annual surveys. And we kind of mapped it into the Chinese industrial classification system, and we got the city level data because we are interested in the city interactions across borders. And the time period is from 2006 to 2019. That's because 2006 is the year that the boom of robots started in China. And the air pollution, we use the PM 2.5, which is the main pollutants in China. And the annual global satellite-based estimate is the proxy. So for other variables, there are some economic and environmental indicators. They are derived from the statistical yearbooks from China.
I have a question about the mechanism. So you are kind of claiming with more robots, the company is getting more competitive, but it is also likely that this company is per se like competitive, and that is why they have more robots, and that is why those less competitive firms will naturally move to neighboring regions, regardless of the robot or not. And also, I'm considering like the price of robot differs across industries. So in some industries, the robot is not very expensive, but in some industries, especially like those handmade to replace that kind of task, that is very expensive, or considering those kind of things.
Yeah, so the different effects of industries would be very important. And in this paper, we do not distinguish this industrial effect. We only look at different cities interaction. And so your first question is?
The first question is, they are probably more competitive, regardless using robots or not. And that way, they will push those less competitive firms to neighboring countries, to neighboring regions.
Yeah, so that's back to
why that is because robot instead of.
Yeah, so in this paper, actually, I'm not dealing with the causal relationship. So what I'm trying to do is to explore whether there is such a phenomenon, and if so, what might be the reason behind. So I would admit that that would not be a causal relationship.
Is it possible that they're just replacing people who are commuting less and using less transportation? If a lot of the PM2.5 is safe in transport, with less employment in factories,
that would be our control variables in this paper. So like the demographic variables and the economic development will be controlled. And we have the fixed effect for the city and the years effect. So this is the result of a spatial correlation test.
Sorry, just again on the mechanism. So what you said, do I understand it correctly that mostly what you have in mind is like a composition effect? That some firms are staying and other firms are leaving? Or is it also that the robots in and of itself are like, I mean, I can imagine that the robot is somehow changing, there's like a within firm treatment effect that like you get cleaner by installing better machinery or something like that?
So we actually have put forward two hypotheses. The first one is that when you introduce the robots to an industry or company, it will make the industry cleaner as it can use the automation and it will lower their cost. And the other externality is what I have just showed here. So this is like a second externality of industrial robots by changing the competitiveness of companies. And the first one, we think that there are already some literature talking about it, so I didn't mention it in detail, but this will also be included in the model. So this is the spatial correlation test. And as you can see in this table, the Moran's index value are significant. And this just shows us that our data of PM 2.5 is spatially autocorrelated, which means the spatial model is more suitable in this case. So here is the model we used. We used the spatial Derby model, which considers the spatial correlation of dependent and independent variables. And this is our model. So on the left-hand side, we have PM 2.5 in logarithm, and we also have it on the right-hand side because this is a spatial model. And the key variable here is the IREXP, which means the industrial robots exposure in each cities in different years. And we have different control variables. And for this spatial model, we use two weights. The first is the geographical adjacency weight, and another is the geographical distance weight. They are also very popular choices in spatial model. And we have included the city and year fixed effects. Okay, so this is the baseline result. So unlike non-spatial model, spatial model would include the circular feedbacks of dependent variables and independent variables in the local and the nearby areas. So we cannot simply look at the first two lines because they cannot reflect the marginal effect of our variables. Instead, we should look at these shaded three lines here. So the first is the direct effect. As you can see, this is a minus number and it is significant, which tells us that more robots will kind of lower the local PM 2.5, and the lower PM 2.5 means cleaner air. Oh, do you have a question?
Yeah, sorry, I might have missed this. Are you thinking about a time term? So kind of what's the counterfactual? I think some of the questions are going at it as well. What would have happened to the same firms without the robots?
I'm not sure if I understand correctly. So in the introduction of robots in this process, there will be a lot of other events, right? So and I will talk about it later. So yeah. So for the direct effects, as I said, more robots will make the local PM 2.5 lower. So it means we will have clean air in the local place. And with this in mind, we can have a rough estimation, which shows us that cities with the highest exposure to industrial robots can experience a 60% of reduction in PM 2.5 concentrations. And for the indirect effect, this is a positive number. So this positive number tells us that if there are more robots in the local place, there might be higher PM 2.5. Oh, okay, there will be a higher 2.5 in the nearby place. So it means we'll have dirtier air in the neighborhood. And here we try to have a look at whether the geographical location and the urban scale would have influence on the nearby transfer effect. And we find an indirect cleaning effect in the metropolis and in the eastern areas. And that might be because in these areas, they will have a strong climate to innovate, to get competitive, like to innovate in green technology instead of to move to other places. And this is the quantile regressions of PM 2.5. So from the left to the right, we have in the interaction terms of robots and PM 2.5. So because this is interaction terms, so we should look at the sum of these two numbers. And we find that if this is in the clean areas, robots will pollute the neighbor and the local at the same time. But for areas with poor air quality, robots do not pollute neighbors. So that's something that are different from the baseline result, because baseline result is actually an average effect. So here we're going to explore the micromechanism behind. And first, we will see how the distance would influence this pollution transfer effect. As you can see in this picture, so first, the effect of RPNT would peak at 19 kilometers, and then it will diminish after 150 kilometers. That is consistent with our hypothesis of firm relocation, because if a firm is in the local and nearby areas, it will have like similar impact of industrial robots and the environmental regulation. So they won't bother to move. But if the distance gets larger, then the cost of relocation would be higher. So they won't move as well. So that's why you have this shape. And to further test our hypothesis, we try to answer this question, whether the industrial structure changed due to the introduction of robots. So here we have the amount of output value of pollution-intensive industries and the proportion of the output value of pollution-intensive industries. And we find that the value for the P ratio are significant. So it means that the proportion of the output value of pollution-intensive industries have increased, which shows that when the robots are in the local area, the pollution-intensive industries are more likely to move to other places. And we also check the impact of relocation costs. So here we have included the external cost and the internal cost. External cost includes like the transport connectivity, and imports includes the wage of employees. And we find that the higher the cost of relocation, the less the PMT would be. So this is also consistent with our hypothesis of firm relocation.
Question, because what matters here is exposure rather than concentration in terms of the PM. So you know where they move, is it like less or more populated areas? Do you know anything about that?
Sorry, could you? No.
So if, for example, because what matters is if people actually inhale the pollution. So if I move and I pollute more, but no one lives around, it doesn't really matter. Even concentration can go up, but it's in a different place. I know that China tried to do that, move polluting activities away from major cities. So do you know anything about that? Where they actually moved, and it's that, you know, there's more density or less density populated areas?
So there are some examples in reality that, okay. So in the big city nearby, like Beijing, it has some like small cities around, and they will kind of some enterprises would move them to the small cities. And lastly, I would like to, the last thing I would do is to rule out other possible confounding factors, because someone also asked that before. Because this is quite important, because if we don't rule out these confounding factors, then the pollution nearby transfer effect would be overestimated. So here I try to include many variables that are related to the contemporary events that happened in the same process of introduction of industrial robots. And we didn't find that the estimated effect of industrial robots diminishing. So that may support our hypothesis. Okay, so lastly, to wrap it up, the first thing we have found is the presence of robots can mitigate air pollution in the local area, and it can also pollute the neighboring areas. And we identified both heterogeneous and the rebound effects of robots on air quality, and we find larger effects in cleaner area. And the mechanism behind could be industrial robots will shape different companies' relocation choices by shifting their competitive advantages. And for the policymakers, we think it is crucial for them to think about how to minimize these externalities.